Is Odilo Mdimi. I'm a student at the Florida International University, and still working on my project. My dissertation is on wrongway driving on Florida freeways. They are implementing a lot of wrongway detection countermeasures, so I'm trying to evaluate the impact on the freeways. Thank you.
Yes.
Might have to turn that mic off if you're both up there because it'll feedback.
Perfect. These are the controls at the bottom. Perfect.
Yeah, so this is just a slide of our team member, Angelina. She couldn't be with us here today. She's an undergrad, and this was the most interesting part of this competition. It was trying to keep together the knowledge from the undergrad students to the graduate students, because both of us are doing PhDs. So it was a nice way to also mentor the undergrads into the software. And thankful to our advisor, Dr. Priyanka Luri, who guided us through the process. Okay, so yeah. Adaptive cruise control is a part of the big picture, the advanced driver assistance systems, and there's so many features that are within others, like controlling your lane, parking, reducing blind spots. And for this competition, our main focus was the adaptive cruise control. So most of us know what is adaptive cruise control, and we probably have it in our cars, and we never turn it on sometimes. But yeah, so this helps us to adjust our speeds automatically to create a safe following distance between you and the vehicle in front of you. And different manufacturers use different features like the radar, lidar, cameras to detect, in order to help to detect the vehicles that is in front of you. And yeah, so the main benefit really is just to reduce the stress from the driver. Sometimes you're driving at night, you're almost like feeling sleepy and everything. So when you turn this on, when you're on the freeway, it can help you to reduce that stress level as you're driving to control your speed. So Steve explained about the competition. So really it's about helping the freeway merging section where like there is a lot of congestion when people are trying to get in the freeway from the ramp. So in this competition, we were trying to see what is the impact of the adaptive cruise control when people are trying to merge. And since the penetration of these vehicles is not yet fully, we did scenarios based on different penetration rates, like from 0, 25, 50, 75 to 100. This is just a picture view of the study area, which Steve already mentioned. It was I-5 in Billman Drive in California. And since it was just a small competition, we just took a small, like 3-mile section, and they provided us with the data set for 3 days, January 24 to 25. The highway speed is 70 miles per hour. And the data was from the California Department of Transportation Performance Measurement System, the PEMS. They provided us with the speed and volume data set, which was in like 5 minutes. So we had to do the aggregation to 15 minutes and then get the peak hour rates for the simulation purposes. Yeah, so the cycle, I don't know if this thing is working, is the section that we were observing where the vehicles on the ramp were merging into the freeway, trying to see the stop and goes and the movements that were ongoing there. Obviously, we had to calibrate our model at the base level after inputting all the data, checking if there are any errors, and also to see how much of the traffic volume that is simulated in the field, what is the difference, the speed changes, and also like the travel time. Yeah. So as I explained earlier, we did different penetration rates. We had to create vehicle classes for the ACC and the non-ACC, and likely this Vissim version that we were using already like had that feature. And then we had different models with different penetration rates of these ACC vehicles. And then Vissim had different parameters, car following and then behavior parameters, which was the gap time, 1 second, the standstill, braking, tow, and the jerk. So we did simulate using the Vissim default, and then we also tried to adjust it, even though this modified are not like implemented or already being done by the manufacturer. It was just something hypothetical just to see what's going to happen, but mainly was based on the default Vissim parameters that were there.
So now jumping to the statistical analysis, we used the statistical package from the social science, that is SPSS, that is the tool most of the engineers and social science use when doing the analysis. So we used analysis of variance, that is ANOVA, because we had to compare multiple groups, that's 5 groups penetration rates, that's 0, 25, 50, 75, and 100. So we could not use the t-test that is limited to when comparing 2 groups, but for the multiple groups, when you want to compare multiple groups simultaneously, the best way in the statistic to use is the ANOVA. So the goal was to compare the difference in means between the penetration rates, that's 0 to 100. This is the 5 groups. So we set our null hypothesis, like there is no difference in means between the performance metrics, and our performance metrics were the speed, travel time, and vehicle counts. And the alternative hypothesis were like at least one group is different from the other. But to detect what's the difference, which group differs from the other, that's why we had to do the post-hoc analysis. That is to see maybe the differences between maybe 0 and 25. So that's the reason of doing the post-hoc analysis. So these are the results after collecting the data. So we tried to bold. The bolded are the ones that were statistical significant at 95 confidence interval. You see so we have 2 tables here, the default value and modified the value, the one below. But I'll focus on the default values on the top. As my friend has explained, the one on below, like we tried to change the values on Vissim. They are not much tested to see if they are valid. So these are the default value, the top table. So 0, when compared to 25 penetration rate, there was no statistical significance between these 2 groups. But when you compare 0 and 75 penetration rate, you see the speed increase is 13 mph, and 0 and 100 is 15.5 miles per hour, and 0 and 75 is 13, and 0 and 100 is 15.6 approximate mph. The rest, there was no statistical significance on the other groups. This is the same thing, but we tried to show the figure between the varied, that we tried to change the variables, like to change the parameters on Vissim and the default and the varied. You see the varied is, the speed is much bit higher compared to the default value, but yeah, but in terms of statistical significance, based on the previous slide, it is just on 0 and 75, 0, 100, 25, 75, and 25 and 100. And this is the travel time as well for the main line and on lamp. So for the main line, the statistical significance was on 0 and 50, that the travel time reduced by 43, these are in seconds, they note in seconds, and 0 to 75, the travel time reduced to 48 seconds, and the 0 to 100, compared to 100, the travel time reduced to 50 seconds. that is on main lines. And on the travel time reduced by 0 to 50 is 26 seconds, 0 to 75 is 29 seconds, and 0 to 100 is 30 seconds. So these are the varied parameters. I will not talk about these. This the same thing I discussed on the table, but I'll not discuss about this figure. So these are the vehicle counts. That was another like performance matrix we checked. I'm not sure if you are able to see the labels. We used the maybe, but the concept here, when the penetration rate is higher, the vehicle counts also increases on the merge section, like segment. So you see when the penetration rate is 100, that is the dots in green color. That's the vehicle counts on the merge segment is a bit higher compared to 0 penetration rate. For the default value, that is the varied parameters. And also we tried to check the time space diagrams. So the concept here, the vertical axis is the distance, and horizontal axis is the time in seconds. So the inference area for the merge segment is 1500. So we extended it a little bit so it shows up to 200 feet. But if you see the S curve, that means there was a lot of stop and goes in this merge segment. But in the travel time, you can see it goes to 100 seconds to clear the merge segment for the 0 penetration rate. But when the penetration rate is 50% ECC, you can see the figures have changed. That means, and the travel time was reduced for the same distance. The travel time is now, the max is approximate to maybe 50, the maximum to clear the segment. And now, when you check the 100%, I'm focusing on the default value, it's less than 25 seconds to clear the segment. That means the higher the penetration rate, the travel time is more better. So
Yeah, so this was just a small corridor, very hypothetical, but we still did see some good results and benefits of the ACC. And mostly it was on the travel time reduction, the flow stability, and also like the operational benefit. So I'd like to encourage you all to use your ACC feature if you have it in your car so that you can help improve mobility on the roadways. Yeah, more deployment and maybe testing frameworks can be done by the vehicle manufacturers to help promote this and keep being the guardians of mobility. Thank you all for listening.
Do we have any questions for these, well, both students now?